So today question is 980 unique paths third, and let's begin from the question. Okay, so the question is saying that we have given an m cross n integer array that is known as grid. Now where grid I and j could be what? See, because grid is m cross n means that is a 2D array, you can say. Okay, first thing we have to given. Next, what we have given? one represent one representing the starting square. There is exactly one starting square. Okay, so there is exactly one starting square, and two represent the ending square means we have exactly one ending square. So two things we have to be clear: one starting, second is ending. So this is given at only one time. Okay, exactly one time we have given. And it is saying another part: 0 represent empty square, we can walk, right? And -1 represent obstacle that we cannot walk, right? So and 0 is to go, 0 is to go, and 1 will block, right? So four things we have given. 1 means we will start from here, and 2 means we will reach here. So these two will become at only one time, right? And 0 is to move from 1 to 2, and 1 will come -1 will come when then we will not go anywhere, right? So these 4 points are given. Now what we have to do? We have to return the number of 4 directional walk. What we have to do? We have to return the number of 4 directional walk from starting a square, that is 0, right? Sorry, that is 1, that is 1, and to the ending square, that is 2, that I was talking about, right? that that walk over every non-obstacle square, exactly walk over, right? The non-obstacle square, that is what? -1. Okay, so if we'll talk about this example, is given 1, right? First it is given what? 1 0 0 0, right? He is given. Next row he is given that 0 0 0 0. Another row is given, and the last row he has given what? 0 0 2 -1. Three rows he has given like this. So this is our 2D array. Gotcha? Now if we will start from here, right? We will start from here. We will reach to where? This location. We have to sorry. We have to reach this location. Correct? Choose another color. Okay. So what I'm saying, we will start from here. We will start from here, and we have to reach here. So this object, this robot, is at what? At this one that I was talking about, right? 0 0, you can say at 0 0, and then it is going what? 0 1 2 2, right? 0 1 2 at 2 comma 2, at you can say 2 comma 2. It is going to here at this location. So he will start from here. He will start from here, and he will reach here. Got it? And then and we cannot walk over this wall, okay, because this is given -1. This is given -1. Now we have the path to follow, right? What are the path we have to? We'll start from 1, right? So he can walk in this direction. In this direction he can walk, but when we come here he cannot walk here, correct? He cannot walk, but he can walk this direction, right? That's why we have the following two path, right? Either we'll start what? 0 0 0 1 0 2. I was talking about this one. If we'll talk 0 0, this is 0 1 0 2 0 3, right? 1 0 1 1 1 2 1 3 9 2 0 2 1, and this is 2 2, right? Okay, so what is the another path we are talking about? This is our another path, right? So another path we have to start from what? 0 0, then we will move to 1 0, we will move to 1 0 this path, and then 2 0, right? After 2 0 we will move to 2 1, then we will to 1 1, this one, then we will move to 0 0, then we will to the here. Now here we will move to here, and then we will move to what? 1 3, this one, 1 1, correct? And this is next 2 2, we have reached here. So there is two possible path we have, correct? As you can see, similarly we have given this one, and another example is this one. Okay, you pause and you will try to find this path, right? Now we have to understand what, whenever we see the context of grid traversal, so the technique of the backtracking or DFS should ring a bell, correct? So whenever we see a context of what, grid traversal, okay, whenever we'll see the context of grid traversal, the technique of the backtracking is what, DFS, either backtracking or DFS, depth first search. And you know that what is backtracking? Backtracking is a general algorithm for finding all solution, right? All solution or some. So it incrementally build candidates to the solution, right? And we have to what we it can be any, it can lead to any problem, right? Any possible solution, you can say it can lead to any problem solution, right? So there is many ways you can iterate, correct? But in this video we will show how to apply the backtracking algorithm to solve this problem, right? So backtracking is just a concept, right? Algorithm in which we have to find all the solutions to some problem of this constraint. Okay, so I think you already knows. So let me move to the approach one, and you will see that the backtracking. So in 2 or 3 days ago I have created one video in which we have seen this backtracking, and I have talked about the state machine, correct? So if you have not gone through, I'll put the into the comment also on the description of the video. I will pin it, and but you'll try to go to see the uh, this video. You can find also, right? So the state machine we will talk about. The state machine I have talked about, that we have initial state and final state. So there is multiple states there, right? So now we can see that our institution of this program is what we can consider backtracking as a state machine, where we start off from our initial state, and each action we will move to the state from one to another, and there should be some final state where we reach our goal. So as a result, let us find and clarify the initial and final state. We will find initial and final state of the problem. So what is initial state? What is initial state? So there are different types of square cells in a grid, correct? So there are an origin and one destination, right? So 1 to 2, right? This is what, origin, and this is our destination, which are not given explicitly. Initially all the cells are not visited, correct? Between that there is all the cells are not visited, so all have initial state. Now if we'll talk about the final state, right? So we reach the destination cell, correct? And cell filled with value 2, right? So we have visited all the non-obstacle cells, including the empty cells, so filled with 0, and the initial cell is what, 1. So these are given, correct? So now we can then translate the problem as a finding all the path that can lead us from the initial stage to final state, right? So if we'll talk about the initial state, right, here, so initial state we have, and another we have what we have final state here. So if we will move from here to final state, right, so what will happen, there will a intermediate number of intermediate state will come, right, from what state 1 to state n. There can be many possibilities, right? So there is only two paths we can say, consider that we see in the first example. So similarly there is multiple state will come from initial state to reach to the final state, and these state are what, this is called our backtracking, right? We'll say that more especially we can say that we could summarize these steps to implement backtracking algorithm for this problem, and in this following video code we'll see, right, so how we could say that these steps are to implement the backtracking algorithm, right? See, we have taken because we are moving each time with the cell, right? So we will take backtrack and then we'll pass a cell. So if we arrive at the final state, right, what we will say, path count plus plus, and then we will stop. We do not need to move to anywhere, right? So this is our, you can say that these are our base case also, right? So what we have to do, we have to mark the cell as visited, right? First, whatever the cell we will pass into the backtracking, we will mark it as a visited. We have to do the current cell first to mark as a visited. Okay. Next, when we will move to for all the direction, right, we have to make the for all the direction, right? If cell is not visited, right, if that is not visited, and that is not obstacle, for all cells move to, we have to move to all the direction, right? We will move to here, then we will reach here, right, like this, and then we will move to here. So when we can mark this one is visited, right? Now we have to come here, right? We are currently here, let's suppose. So we have to move this direction also, we can move to this direction also. There is two possibilities, right? And then we have two also here, correct? So this is our current direction, we have marked it. If we will move to this direction or this direction, so for loop will move to two direction, right? We cannot move here, that is not possibility, or we cannot go back, right? This is not possibility. So the loop will go for this one and this one. So we will backtrack this position to mark this position as okay, and again for this position, right? And then we will move to here, right? So if we will move, continue here, continue going here, right, continue going here, like that, right? So there is many possibilities, right? And then that will complete the our problem solution, right? So this is our backtracking algorithm, in which we will see if we have arrived here at the final position, we will do path count, and then we will return, right? We will not do anything. If that is not the case, if we are not at the that position, we have to mark that position, right? We will mark this, and then after marking we will move to all the direction. What are the possibility we left, that we will move, and we will do backtrack for the all the direction, and finally we will unmark the current cell, right? Because we may have to traverse that that path also. Now we will see that algorithm, right? So we will make two program here, sorry, two function here. The first, to backtrack the problem, right, we will pass row, column, and remaining, right? And this is our function that will take the graph, the grid, right? 2D grid it will take as a input. So let's see in the code section, and we'll see that how to implement that. Okay, this function, right? And before that, what we have to do, we have to do backtrack, right? So we can take a backtrack function, and then we can implement the backtracking function, right, as we have discussed, right? So either we will start from here, or either you can create a backtracking function, right? So what I will talk about, we have to initialize our int non obstacle, right? So what is our non obstacle? Okay, yeah, this is our non obstacle. you can say, and we will start from what, 0, and then we'll say there is a start row that we have to pass start underscore row, correct, and that will start from what, 0, and we'll take a start column also, start underscore what, call, that is also start from what, 0 only. So these three things will take non obstacles 0, start row 0, and column is 0. Now we have to take some variables, right, for the class, and that is what, that is our we have to take instance variable of this class, right. So that is our, if we'll talk about int, then we'll take rows, and these rows and the columns, okay. Then what we have to do, we have to take integer array, right, we have to take integer 2D array, and this is what our grid we have, right, and the first, and this will we will map it later, right. Then we'll do path underscore count, this is the value, right, three things. Now this grid is already given, so we will do what, we will do this dot row equal to what, this is grid dot length, correct. Next what we have, column, this dot columns equal to what, grid at 0 dot length, right. So these two things are done. Now we will initialize the condition, right. So we can say that this is our step 1, right, that we have talked about. Step 1, we will do initialize, right. We can initiate our what, we can initialize what, the conditions. We will initialize the condition, let me write a full condition, and the conditions are what, condition for backtracking, condition for backtracking, and that is, if we'll talk about, that is what, that is our initial state, right, initial state and final state, correct. What I told, the first step is what, our we have to initiate the condition for backtracking, and that is initial state and final state. So how we will do that, we have to make a loop, right, we have to make a loop, that is for loop, and this loop should start from what, int row equal to, we will take 0, and then row equal to what, so less than rows, correct, and then we will take plus plus row. So we are here, for each row we will move to each column, correct. So we will make a nested loop here, and we'll say that int cell, right, for each cell, not column, we'll say each cell, right. So cell is what, we have to start from we can say column also, no problem. So int call, for each row there is a multiple column, right. So we'll start from int call column, each column from 0, and that is column is less than what, all columns, right. So columns, right, all calls, right, and then the plus plus call, got it. So for each row we will move to each column, right, which for each row there is certain number of columns, right. Now we will take cell, and cell is what? Our grid cell. We will pass 0 0 means we have to pass row and then column, right? This is our 0 0 means our will start from uh, starting index, right? So that will do that. Now we'll check if cell value is greater than or equal to less, like this. Okay, greater than equal to what? 0 we can say. Then what we should do? We have to initialize sorry, we have to update this initialize value of non-obstacle is plus equal to what? 1. Correct? If that is not the case, means cell, we are talking about cell, right? Means cell is what? Equal to 1. We have to make equal. If cell equal to 1, it means we have to go to what? We have to update our start and column, this one. Correct? Start we will update and we'll update our column. How will update? This will our start is row and this is our call. Correct? So two things we have done here. Now think about these two cells, right? These two, right? We are out of the loop now. Now here we think that we have to do what? This and then path count, this one. And path count is here what? We have to initialize as a 0 only. And then this dot grid equal to, we have to grid. Now we have to do kickstart the, now we have to do kick off the backtracking, you can say. Kick off the backtracking. Right? How we will do that? We will make a function later. We have not created now. We will do backtrack and we'll start what? We'll start from starting row and then starting column and then non-obstacle we have to also pass, right? Because we are doing what? We are doing backtracking, right? So these three will pass and this will backtrack our start row column, right? Now after this, what we can do that? We can return our path count. This dot our path count, right? So what we have to create? We have to create backtrack function. Like we can do, we will do that backtracking. And how we will do that? So we will pass start row, column and this one, right? Let's create here only. Here. How we will do that? We can make public or protected also. Protected will take. Protected void and backtrack method name that we have used at line number 29, and we used to pass what? Int row. First we have passed a starting row, then we have started int column, starting column, and then int remain, because we are not using the same because it will backtrack and we will update the start column to another column also. So we will start dynamic value name row call and obstacle is nothing but a remain. Okay. Now how we will do the backtrack? we have to create first base case of the terminated, you can say base cases of the termination of backtracking, you can say, because if we will not terminate the backtracking, it will go till the end, it will do infinite, right? So that what we have to do, we have to make if condition, and we'll check this dot grid at row and at column, at row and column of certain is what, equal to 2, and we can say and remain is equal to 1. Two things we have, remain equal to 1 and grid of row and col is equal to 2. Then what we have to do, right? We have reached, it means we have reached what, the destination, we have reached the destination, and so we can say we have to update our path count as what, equal to 1. We have to increment by 1, and we do not need to do anything, we'll return, we do not need to do this one, right? So this is our base case, and so that we can terminate our execution here. Now step next, what we have to do, we have did base case of the termination of the backtracking. Now if that is not the case, we have to mark the square as visited cell, right? Now what we have to do, we have to mark the square as visited, right? Like we have the case 0, 1 and 2, right? Now how we will do that, we'll take a int temp and make it as at what, grid at row and then call, and grid at row and call is what, we'll do -4, right? Then remaining is what, we'll do remain as -1, will decrease with 1, we'll do -1. Why we are doing here, because we now have one less square to visit, right? Okay, and we have to explore now our 4 potential directions, right? So in the next step we will explore the 4 potential direction around, you can see. How we will do that, we'll take int row underscore offset, how we will pass 0, 0, what, 1, -1, correct? All 4 direction is here for all the offset, right? We have row offset. Similarly we have to do column offset. Int, this is very important to understand. Column offsets are what we can say. This is, we'll start with column at 1, at -1, 0 and 0, right? These are our offsets for row and column, so that we can explore all the 4 potential directions. Now what is important here is that we have to make a loop now, right? So that we can move all the direction. How we'll do that? We'll start from int I equal to 0. I should be less than 4, right? All 4 directions we will move, right? And then we will do plus plus I. Understood? Here we'll take next underscore row, and it is what? Column plus you can say row offset. This is our row offset, right? Row offset at I, 4 for all the directions, right? We have 4 offsets. Similarly, we'll copy this and we'll paste for next column. Next column will come from what? Sorry, we have to do row plus, right? Row plus. And this next column is what? Col plus col offset. Now we are clear, right? Row, now next row, next column is here. Now we have to make some conditions. How we'll do that? We have to write if 0 is greater than this next row. If 0 is greater than next row, or we can say, or next row is greater than equal to this dot row. Correct? Are you getting? We are doing what we are doing? We are doing if 0 is greater than next row or row is greater than column, then there will be more condition, right? Or similarly, 0 is greater than what? Next column. 0 is greater than next column, or next column is greater than equal to what? This dot column, right? This column. If this is the case, means we are at invalid coordinate, right? Coordinate. Please check the spellings, okay? And if that is the case, we will continue this step, okay? And we'll also check if grid at next if grid at next underscore row, right? And row and column, if grid at row and next is less than 0, means what happened? Either we have obstacle, right? either we have obstacle, let's check the spelling. Okay, either we have at obstacle or visited square, right? Then we will do what? Nothing. We will continue our work, right? And what is our work here? The backtrack of this function, right? How we are doing? We are passing backtrack, and then we are passing our next row. We are starting passing a row, then we are passing column, and another was I think remaining, right? Remain we have taken. Let's see here. Let's see where what we have choose. Yeah, remain. Okay. So I think we are almost done. One more thing what we have to do after this, we have to unmark, right? Unmark. We have to unmark the square after visit. After visit, right? Then what we will do? We will do greet at row and call equal to temp. Understood? We have taken this temp and we have stored, right? Let's compile this code. It's working fine. Let me submit this program. Yeah. So thank you guys.